You're welcome yet again to another class, Maths Made Simple 247. This morning we'll be looking at the topic Cirlce Theorem. Now, I've actually prepared this lesson for students who I feel can use match picture and theories together. Circle geometry is one of the complex topics to teach, and it shouldn't be taught in an abstract way. So the lesson so prepared here will help the student. Here is a diagram that you will look at and then know the various parts that are labeled there, so that when we talk about it, you will know what we are referring to as far as circle is concerned. Now let's look at our first fact here. Any triangle AOB with A and B on the circumference and O at the center of a circle is isosceles, as you can see in the diagram. So you know, when you see this diagram, you should know that lines drawn from center to any part of the circumference is radius. Alright. Fact number 2. The tangent to the circle is perpendicular to the radius at the point of contact. Okay. Now for teachers, you can actually use this to teach your students or use this to prepare your notes. It's important we learn this fact, and it's important we keep this fact at heart, because you could see other diagrams and then use it to teach your students. Fact number 3. The triangle produced by two crossing tangents is isosceles. It's isosceles, as you can see. Okay, I hope this fact sticks to you. Let's go to the fact number 4. If a radius bisects a chord, it does so at right angle, and if a radius cuts a chord at right angle, it bisects it. It bisects it at angle 90 degree. Okay, so we will be looking forward to, I think at this point we can go ahead and start with the theorems. I believe you can understand the 4 facts here that has been stated. Let's go with the first theory. The angle subtended by an arc at the center of a circle is twice the angle subtended at the circumference. That is, angle at the center is twice that at the circumference, as shown in the diagram. Alright. It is not just enough for us to teach these theorems in abstract. It is good, as you are stating the theory, there are diagrams to actually back up this theory. You can see. Okay, theorem number 2. The angle in a semicircle is a right angle. Angle in a semicircle. The angle in a semicircle is a right angle. Okay. Now, having done this, I think we can now move to theorem number 3. Angles in the same segment are equal. Angles in the same segment are equal. I believe you can see for yourself. So you can actually make notes out of this. You can make notes out of this, because after this lesson, I'll be taking a practical class. Now, theorem number 4, the sum of the opposite angles of a cyclic quadrilateral is 180. As you can see, the opposite angle in that cyclic quadrilateral, if you sum them together, it gives you 180. Okay. I want to believe that you're finding this class interesting. Please like this channel and share it. Let's go to theory number 5. The angle between a chord and the tangent at the point of contact is equal to the angle in the alternate segment. Is equal to the angle in the alternate segment. This is called the alternate segment theorem. Circle theorem number 5. Okay, having learned this now, generally let's look at this diagram here. Okay, let's look at this diagram here. Like I said, when a line is drawn from the center of the circle to any part of the circumference, that line is usually referred to as the radius. Okay, and then if it forms a triangle, as you can see, it forms an isosceles triangle. and the base angle of an isosceles triangle, of course, they are equal. Okay, randomly we're looking back at what we've done before. As you can see, angle in the same segments are equal, and angle at the center is twice that at the circumference. Okay, I like to play with this as much as I can, but I want to urge you teachers, please don't teach this in abstract. Please make the students to understand this concept using diagrams. Alright, as you can see, I've stated this before. Angle at center, of course, is twice that at the circumference. And you can see this is a clear example of what we're talking about. Please make notes with this, and please don't teach this in an abstract form. It is better the students match the diagram with whatever theory you're trying to teach. And this is a material that the teacher can actually use as a lesson material for their class. I want to thank you very much for the time spent here. If you like this video, please like and share this video. Thank you very much for your time. See you next time. Thank you.